Hello children and welcome to today's session. Children, we see many kinds of things around us. We use a pencil that is made up of wood. We also use a metallic pencil which has got a black color lid in it. We use notebooks, we use different kinds of cardboards. Some are very hard, some are very soft. Even the cutlery or the crockery that we use at home comes in different kinds of materials. Now, all these materials basically originate from two things. They can be metals and non-metals, which is chapter number 4 of your book. We all know that all the things around us are made up of different molecules. And these molecules contain atoms in them. When the molecules in a substance are of the same kind, they are known as element. And elements exist in their natural form. And these elements can be divided into metals and non-metals. Children, it is a fact that there are about 118 elements known to us. Children, of these, metals are known to be very lustrous, they are hard and can be drawn into wires. Whereas non-metals are very brittle. They are poor conductors of heat and electricity. So in this chapter, we are going to learn in detail about the characteristics of metals and non-metals. So let us understand first about the physical properties of metals. The physical state of metals. Metals are generally solid at room temperature, but there are two exceptions here, mercury and gallium. They are liquid at room temperature. Next, let's come to the hardness. Metals are generally hard. They do not break easily. But metals like sodium and potassium are soft, and metals like gold and aluminum are not very hard. They can be shaped into different shapes. Next comes tensile strength. Now, because they are hard, of course, their tensile strength is going to be very high. If you put strain on metals, they are not going to break very easily. Luster, metals are very shiny and this property is known as luster. They can be polished. Gold, silver and copper can be polished, and we all know that gold and silver are used for making jewelry. The next is the melting point and boiling point of metals. Metals generally have a high boiling point and melting point. Sodium, potassium and mercury are an exception. Let us now understand about the property of malleability. Metals are malleable and brittle. The property of metals to be hammered into thin sheets is called malleability. Take a piece of aluminum metal and place it on a block of iron. Beat it with a hammer. You will observe that the aluminum metal turns into a thin sheet. This property of metals is used to make utensils of copper, jewelry of gold and silver. Some metals like zinc and arsenic are brittle. They break easily on hammering. Metals in gaseous and liquid state do not show the property of brittleness. Another important property of metals is ductility. What is ductility? Ductility is the property of the metals by which they can be drawn into wires. So we all know that copper is used in making wires. Conductivity. Metals are good conductors of heat and electricity. And the exceptions are bismuth, tungsten and lead, which are poor conductors. Metals, because they are hard, they are also sonorous. That means when you are going to strike the metal with a hard object, it is going to make a ringing sound. Let us now understand the physical properties of non-metals. Entirely opposite to the metals, physical properties or the physical state of non-metal can be solids, liquids as well as gases. So, elements on non-metals such as carbon, sulfur and phosphorus, they are solid at room temperature. Bromine is the only non-metal which occurs as liquid. And we all know hydrogen, nitrogen, helium, all these are gases which are also non-metals. Hardness. Non-metals are not very hard, but as an exception, diamond is known to be the hardest substance on earth. Because they are not very hard, they of course have a low tensile strength. Then they have liquid and gaseous forms also. Carbon fiber, which has a very strong tensile strength, is an exception. Children, non-metals are non-lustrous except iodine and graphite. They have a low boiling point, but again the exceptions are graphite and diamond, which have a high melting point. Non-metals are very brittle, so that means they are non-malleable. And because they are brittle, they obviously cannot be drawn into wires, so they are also non-ductile. Now you can actually prove the electrical conductivity of various materials. This can be done with a simple experiment using a simple circuit that is made up of a cell, a wire, a conducting material and a bulb. You can do the experiment in your school lab under the assistance and guidance of your teacher. Let's talk about conductivity of non-metals. Non-metals are generally bad conductors of heat and electricity, but graphite again is an exception. Sonorous non-metals are not sonorous. And next we come to chemical properties of metals. So in the chemical properties of metals and non-metals, we will get to know how they react with different things. So let us first understand the reaction with oxygen. Most metals, when they react with oxygen, they form basic oxides, as in case of magnesium, which forms 2MgO, that is magnesium oxide. Now, if you react magnesium oxide with dilute sulfuric acid, it forms magnesium sulfate and releases water. This shows that magnesium oxide is a basic oxide. Some metals such as sodium react with oxygen even at room temperature. That is why they have to be kept in water so that they are cooler than the temperature inside the room. And metals such as copper and iron react with oxygen only at a very, very high temperature. Next, let's learn the reaction with water. So as we just understood, sodium, potassium and calcium, when dropped in water, react vigorously and they produce bubbles. Magnesium only reacts with hot water or steam to produce oxide, which is magnesium oxide, and releases hydrogen gas. Zinc again reacts only with steam to form zinc oxide. Aluminum forms aluminum oxide, which gets deposited on aluminum and stops the further reaction. Copper, silver, gold, nickel do not react with water or steam. They are called stable elements. Children, you can prove that metal oxides are basic in nature with its activity that is given in your book that can be easily conducted using a magnesium ribbon, a pair of tongs, a burner, water and testing it by litmus paper. And this experiment should be conducted under the supervision of your teacher only. Next, let's discuss the reaction with hydrogen. Metals generally do not react with hydrogen. Only very, very reactive metals form hydrides and hydrogen. Reaction with dilute acids. Most of the metals form respective salts. When they react with dilute sulfuric acid and dilute hydrochloric acid. Now, metals such as gold, silver and copper do not react with acids. Reaction with other metals. This is known as a displacement reaction. Now, let us first understand a displacement reaction. For example, if there is a compound AO2, it reacts with a metal B. Now, if B is more reactive than A, then B will replace A in this compound and make BO2. In case B is not more reactive than A, then nothing will happen in this reaction. Now, how do you understand which metal is more reactive than the others? You study the reactivity series of metals. In this series, all the elements are placed with most reactive metal, that is potassium, on the top, and the least reactive element, gold, at the base. Now, depending on the reactivity of metals, they are going to carry out the displacement reaction. You can also study how a displacement reaction takes place by taking a solution of copper sulfate and an iron nail. It is a very, very interesting experiment given in your book that should be conducted under the supervision of your teacher. Children, this kind of reaction, when a metal displaces a less reactive metal from its salt solution, is known as a displacement reaction. Now let's come to the chemical properties of nonmetals. Let us first begin with the reaction with oxygen. So we know that nonmetals form acidic nonmetal oxides. SO2, CO2 are acidic nonmetal oxides, whereas H2O is neutral nonmetal oxide. Reaction with water, they do not react with water. Reaction with hydrogen. Nonmetals react with hydrogen to form their corresponding hydrides, which are quite stable in nature. With dilute acids, they do not react with dilute acids. Based on the properties, different physical and chemical properties that we've just learned, metals and nonmetals are used for different things. Let us take them up one by one. So, we'll first study the uses of metals. Now, because the metals are malleable and ductile, they are of course used in the making of articles such as utensils, chain, nuts, bolts, nets, wires, pipes, sink tanks, almirahs, cylinders, and the list is never ending. There are so many things around us that are made of metals. Copper is used in making electrical wires because one, it is ductile, and second, it is a good conductor of electricity. Aluminum, again because it is a good conductor of heat, it is used in making cooking utensils. It is also used in making fittings and a variety of other things. It is also used in making utensils, body of aircrafts, buses, cars, etc. because it's a very light metal. Chromium is electroplated on iron. This makes iron resistant to corrosion. And this electroplated iron is used to make handles of cycles, motorcycles, etc. Lead is used to make electrodes in automobile batteries. Tin is also used as a coating on iron to make cooking utensils. Zinc is used in dry cells. Then let's come to the uses of nonmetals and let's understand these through a short video. Nonmetals are useful to us in several ways. Oxygen is essential for all living things to respire. Phosphorus and nitrogen are nonmetals used in fertilizers. Graphite is used as an electrode in electric cell. Diamond is used to make jewelry. Sulfur is used to make dyes, matches, gunpowder. Chlorine is used to disinfect water. Iodine is used in iodized salt. So children, in this chapter, you have learned what metals and nonmetals are. You have learned the difference between their physical and chemical properties. You have also learned how these are used in our everyday life. So we hope that you've thoroughly enjoyed the chapter and are ready to attempt the questions at the back. Thank you.